All right, welcome back. So in our last explainer, we looked at JavaScript's simple, primitive values. But what about everything else? Today, we're diving deep into the absolute foundation of all complex data in JavaScript, objects and their hidden power, prototypes.
Right. So, we've already covered those 7 primitive data types, the simple, unchanging building blocks of the language.
But that leaves a huge question. What about arrays, functions, dates, all the complex stuff? Well, in JavaScript, the answer is simple. If it's not a primitive, it's an object. Let's really unpack what that means. So what exactly is this fundamental data structure? I mean, what is an object when you get right down to it? At its core, an object is just a container. It's a collection of key value pairs. You can think of it like a car in the real world. A car has properties, right? A color, a make, a year. A JavaScript object is the exact same idea. It bundles up related data under named properties.
Now, there are a few ways to build one. The one you'll see everywhere is the object literal, just using curly braces. It's clean, it's simple. You can also use a constructor function with the new keyword, or even Object.create when you need really fine-grained control over its inheritance.
And once you've got an object, you need to get the data out of it. Dot notation is usually the go-to. It's easy to read and write, but bracket notation, that's where the real power is. It lets you use variables to decide which property to access on the fly. Super flexible. Okay, now for the big mystery. Let's say we create a super simple object, right? Just one property. How is it that we can call a method like toString on it, and it just works? We didn't define that method, so where did it come from?
The answer lies in a special kind of hidden property that every single object in JavaScript has. And understanding this is the key to unlocking JavaScript's entire object model.
This whole idea is called prototypal inheritance. It's a feature where an object can essentially borrow properties and methods from another object, and that other object it borrows from, that's called its prototype. To really get this, let's build a mental picture. Imagine every object has this internal, hidden property called prototype. So let's start with a simple rabbit object that has one property, jumps. Now that hidden prototype link inside our rabbit object can point to another object. Let's say it points to an animal object. Just like that, animal has become the prototype for rabbit. But it doesn't have to stop there. The animal object, it also has its own triple prototype link, and that might point to an even more general master object called Object.prototype. Eventually, the chain has to end, and it does. The prototype of Object.prototype is just null. This entire sequence of linked objects, that is the prototype chain. It's the absolute heart of how code is shared and reused in JavaScript. Okay, so we've got this chain of objects all linked together. How does JavaScript actually make use of it? Here's the key takeaway. When you try to access a property on an object, JavaScript first looks at the object itself. But if it's not there, it doesn't just error out. No, it follows that triple prototype link and checks the next object in the chain. It keeps climbing up, link by link, until it either finds the property or hits the end of the line at null. Now let's zoom out for a second. This whole prototype thing isn't just for objects we create. It's the foundation for the entire language. I mean, think about it. JavaScript gives us a ton of built-in tools right out of the box. Things for handling dates, math, creating arrays, dealing with errors, the whole shebang. And here's the magic. Every single one of these built-in objects, from a simple array to a complex function, has a prototype chain that leads all the way back to that one common ancestor, Object.prototype. That's where methods like toString and hasProperty live, making them available to almost everything in JavaScript. Now, as a developer, you're going to run into situations where you need to know, is this property directly on my object, or did it inherit it from somewhere up the chain? And for that, JavaScript gives us 2 main tools. HasOnProperty is very specific. It only returns true if the property exists directly on the object itself. The in operator, though, is more relaxed. It'll look at the object and its entire prototype chain, returning true if it finds the property anywhere along the way. Speaking of inspecting things, you gotta know about the famous quirk with the typeof operator. It correctly tells you that an object or an array is an object, but it also tells you that null is an object. It's just a little historical bug from the early days of the language that's stuck around ever since.
So we've seen how prototypes work, but why? Why does any of this matter? What's the real benefit of this whole system?
Well,
Unlike other languages like Java or C++ that use what's called classical inheritance with rigid class structures, JavaScript's prototypical model is incredibly flexible. It lets objects inherit directly from other objects. This allows for really powerful and dynamic code reuse without getting locked into a strict hierarchy.
So let's bring it all home. The best way to think about this is that objects are containers for their own unique data. And prototypes? They're the invisible blueprints that link all these containers together, letting them share functionality. It's this system that gives JavaScript its incredibly dynamic and flexible nature.
Okay, so now that we have a solid mental model for JavaScript's data structure, it's time to see what happens when the language starts transforming that data. In our next explainer, we are going to tackle one of the most powerful and often misunderstood parts of the language: typecasting and conversion.
This is Developer Roadmaps. Map your path, build your career.